In this video, we're going to go over an application problem involving right triangle trigonometry. So here we have a student determines that at a distance 16 feet from a tree, the angle of elevation from the ground to the top of the tree is 60 degrees. Find the height of the tree, and then also determine if the tree is so tall that if it fell directly towards the house that's 25 feet away, it would hit the house. Okay, so there's a couple different things that we need to answer to completely give the answers to what it is asking us to do. Now, one of the things I want to mention is when they talk about angle of elevation. So angle of elevation is if you're looking straight out horizontal and you measure up to see whatever it is that you're trying to view. So that's your angle of elevation. In different problems, application problems with trig, if they say the angle of depression, then that you're looking horizontal and you look down to see whatever it is. It would be that angle if it was an angle of depression. So just kind of to give vocabulary background for that. So we have the angle of elevation from ground. Okay, so I know that it's from the ground level. If somebody was standing up and they had the angle of the elevation to the top of the tree as they were standing, then to get a total height of whatever they were measuring, they would have to add the distance from where their view was to whatever they got from the right triangle trig for the height to get the total height from ground up. Okay, but this is from the ground to the top of the tree is 16 degrees. So if we want to like draw our kind of picture here, we've got our tree. We've got the student from ground level looking at the top of the tree. That is 60 degrees. That's our angle of elevation. And it also says that that student is 16 feet from the tree. So the student taking the measurement is 16 feet from the tree. So the 16 feet goes along that horizontal line. Okay? Now they want us to find the height of the tree. So H, this height of the tree is what we're looking for. Now we're assuming that the tree is growing straight up so that we have a right triangle here that we're finding that height. When I'm doing application problems with right triangle trig, we need to make sure that embedded in that the right angle is in our triangle for right triangle trig. If we don't have a right angle and we can't get some sort of auxiliary lines to help us with that, then that concept or that application would wait until we did things like the law of sines and the law of cosines later on in the trig content. But here we do have that right angle. So if this is our angle that we're focusing on, and we look at the sides of the right triangle that are made, the 16 foot is a leg of the right triangle, and the height of the tree is a leg of the right triangle, and the distance from the person looking to the tip of the tree, that's the hypotenuse. So we've got Pythagorean theorem that could go on in here if we needed that for help. But we've got everything we need to work with it in terms of the right triangle trig. Now, when we're looking at this angle, I want to name the sides of the right triangle that I know or I want to know. And that's how you determine which trig function to use. So I know the adjacent side to the angle, and I want to know the opposite side to the angle. And the trig functions that relate opposite and adjacent are tangent of the angle or cotangent of the angle. But the tangent of the angle is the one that has a calculator key option. So the tangent is the trig function we're going to use for this particular question. Now we're going to set that up. So the tangent of an angle, of that angle 60 degrees, remember, is opposite over adjacent. So in our diagram we get h over 16. And we want to solve for h. So once I get it like this, because depending on the question, sometimes your h or your variable that you're trying to find is in the numerator, sometimes the number's in the numerator and the variable's in the denominator. Write out your equation. and then go through the equation solving process to get the answer. So here I want to get rid of the fractions. So I'll multiply both sides by 16 over 1. And the 16s remove as a common factor pair on the right of the equation. I get h. And on the left I get 16 times the tangent of 60 degrees. Now if you've not done trig ratios of nice angles yet, you'll now go to your calculator and you will make sure in the mode that you're in degree mode, and then you're going to do the tangent of 60 degrees and multiply by 16. And many of them you can just go 16 times tan 60 and enter, and your height will be approximately equal to 27.7 feet. Now, if it asks you to give the answer exact and then round it to the nearest tenth value, the exact, well, 60 degrees is what is a nice angle. And again, if you haven't done that yet, it'll come further into the course. If you have done that, remember that 60 degrees is a nice angle, and the tangent of 60 degrees is the square root of 3. So we would first write 16 times the square root of 3, and then multiply 16 times the square root of 3, round it off, and we would still get that same answer rounded off. So this kind of digresses a little bit depending on what order of the content you're doing, or maybe if you're just doing an application problem, then you'd probably want to just get to your approximation. So that's answers, find the height of the tree. But it also says determine if the tree is so tall that if it fell directly towards the house, 25 feet away, if it would hit the house. Well, if it fell directly towards the house and the house is only 25 feet away and it's a 27.7 foot tree, it will like brush and hit the house. So yes, it would hit the house. So if you were doing this, say, as a homeowner, you might think, yeah, I probably want to take that tree out so that I don't run the risk that if there's a bad storm and the wind hits it just right, that it might like cause damage to my home. So that's even another place where these applications of these trig functions really come in handy, not only just as application problems that they have you do in a course, but also just everyday decision making of things that you can find heights or lengths or whatever it is of things that aren't easily measurable in other scenarios.